Okay, we're looking at Sohcahtoa. So this is how to find angles and sides in right angle triangles. Alright, now the first thing is to really make sure you've got your sides labeled correctly. Alright, I got two triangles here. The one on the left has an angle in the bottom left corner there, which gives me an opposite to the right and an adjacent on the bottom. So you've always got to start with the angle and say, in relation to the angle, what is the opposite and adjacent? You don't need to worry about the hypotenuse because that's always the long side opposite the right angle. But you can see here on the example on the left, because I'm using this angle here, that's the opposite and that's the adjacent. Now in the triangle on the right here, this time, because I'm using this angle up here, that's the opposite down there, and that's the adjacent there. The other thing is, of course, which formula do you use? So which ratio do you use? If it's involving opposite hypotenuse, you're going to use sine. If it's involving adjacent hypotenuse, you're going to use cos. If it involves opposite adjacent, you'll use tan. Let's look first of all, just review an example of finding an angle. So this is using the second function or the shift button on your calculator. So here I've looked at the triangle. Okay, first things first, I identify in relation to the angle, I have the opposite and the adjacent. That means I must be using tan. So I write out my ratio first of all. Tan of the angle is opposite over adjacent, 3/4. And in order to find an angle, I do shift or second function on my calculator, shift or second function tan, and this little -1 thing comes up, and then you type in your ratio, 3/4 or 3 divided by 4, press equals, and you should get 41 degrees. Let's just have a look at the calculator, see how that works there. So you can see on this one I'm pressing second function tan, and there my little -1 comes up, and then in brackets 3 divided by 4, that's opposite over adjacent. And there you can see my degrees, which I've just rounded up to the nearest degree, 41 degrees. Oops, product placement. That was advertising sharp there. Alright, number 2. Find a side given an angle and a side. Well, the same basic principle. Just start with the angle, right? And say, what have you got and what are you looking for? Now here, I've got the hypotenuse and I'm looking for the opposite. This means that I must be using sine because that's the formula that involves opposite and hypotenuse. So again, just write out your ratio. Sine 40 equals, in this case, z over 8. I don't know what the opposite is. I've called it z here. So z over 8 is the opposite over hypotenuse ratio. In order to isolate z, I'm going to have to multiply that 8 up there. It's kind of a cross multiplication, or you can think of it as multiplying both sides by 8. So that I just have z on the right side, and that gives me this result, 4.7, again rounding going on there. Now, I've just done a second example here because sometimes the algebra is a little bit tricky. This time, you write out your ratio. You say, okay, relation to 60 degrees, I've got the adjacent, and I need the hypotenuse. So I must be using the cos formula because that's adjacent over hypotenuse. However, you've got this rather awkward situation here with x on the bottom. So I'm just going to multiply it up here first and get it off a denominator. So at least now I have cos x times x is 3. And then you could see, oh, I'll just divide both sides by cos 60. And that will get rid of cos 60 on the left and isolate x for me. So hence, again, rounding there, 5.1 is your side there. And that's Sohcahtoa, defining angles and sides in right angle triangles in a nutshell.